And I should be able to, okay. So let me come up Moodle. You can get on your Moodle as well now. And I will show you what I mean by the instruction. So, okay, so Moodle, if you go to our unit, which is Bayesian inference for mean, you will see the lab instructions here. So it's Bayesian inference for unknown mean. And also just right above it, it's the C data CSV file that you need for this lab. Okay, so download that and then open this PDF file for the lab. So the lab I try to provide, I think it's pretty much self-contained, but if you have questions or want to refer back to the slides, feel free to do so. But as you can see in the lab instruction, I first of all summarize what the Bayesian inference for the mean is. I give you what the posterior, I give you the sampling model, I give you the prior distribution, then I show you what is exactly the posterior distribution, okay? And then section 2, I introduce a little bit about the CE data sample again, including some sample code that you can use to access like some sample, like say sample mean, which is needed when you're doing posterior computation, okay? And then section 3 is about Bayesian hypothesis testing. I give you the question itself and then ask you to do it 2 ways. And I give you the hint of what you need in terms of the R function. And section 4 is Bayesian credible interval. Again, the question, which is question 2, an exact solution and approximation through simulation. Section 5 is Bayesian prediction. I give you the detailed formula for it. So pretty much you just need to make sure that you know how to implement this in R. But of course, if you don't know exactly how this is done, the prediction itself, you might want to review the book and the slides a little bit. And then lastly, is the posterior predictive checking. I give you the details as well. Okay, so there are 4 questions in total. I underscore the question. So you will see that 1 is from section 3. The second question is from section 4. Third question is from section 5. And fourth question is from section 6. Okay. So read through carefully. I think some of the, we just covered this. So not everyone is super familiar with all of the details. So no worries, just take time to learn. We do have about 45 minutes left today anyway. So I will walk around to answer questions. And of course, just you can talk to your neighbors and then you can work together. But in the end, for the submission, is an individual report. But you're welcome. Feel free to collaborate and then discuss. A lot of the learning will be most effective if you ask questions and work with somebody else. Yeah, so section 2, by the way, like the code that I provided for you, that you can see in section 2, it's up until the point that you get the mu n and standard deviation n. Okay, so if you go to the slides, you can see what we did like afterwards once we compute the posterior mean and standard deviation for the normal mean. Then you can start doing like R norms to generate new draws. But in the sample code that I included here in the write-up, it's only up until how you can compute the mu n and the sigma n. Okay, but you use them. You can use them directly in your answer. Okay, it looks like I should at least talk about a little bit about like the working directory, because now I guess it's the first time that we're getting real data, loading data into R. So let me just demo really quick. So the data set is on Moodle. So you click cedata.csv, you click it, I think it automatically downloads. And I guess most of you are using the local RStudio on your desktop, right? Or like laptop. So what you need to do is you have to put the CSV file and the R file that you have in the same folder. Okay, and what I do now, because I'm trying to just to work simpler, I'm using the RStudio server, but it's the same procedure. So now I'm in my folder, and then what I do is I need to upload the data set into the same folder. So my demo is on the, let's see, yeah. So you can click open, and then now you see I'm working on the script called lab2.r, and then I'm in the same directory as what my cedata.csv is. Okay, so you do the same for you. And if when you try to load the data still not running, one more thing to check is on the top panel, there is a button called session. You click session, and then there's one choice for you to set the working directory. So sometimes, even though you save all of your files in one folder, your R working directory is not there. So when you run it, still doesn't show up. So the way to do it, you set working directory and choose directory. Because obviously I'm not in the right path at the moment. I was, for some reason, in 341. So I go back and then go to 347. So this is my working directory where I save my R file and the data. So you click choose, and then you can start loading the data in this way. So the first, let me just show you the line to CE data. I'm just naming my data set as this, and it's read CSV, because that's how the data is saved. And it's the name of the file, so it's CSV, no, CE data, I think CSV. This should be the command that you can load the data, and you name it as CE data. Okay, so you run it, and on the upper right panel, you will see CE data shows up. Okay, it should have 6208 observations of 2 variables. Okay, so if you see that, that means you have successfully loaded the data into your R. Okay, so I will walk around again because I know some of you might not be familiar with this, and but this is the general procedure to do that. And then I should say in the lab instruction, in the second section, you see that I first of all give you the sample code to take the log transformation. So you need to do this because we've been working on the logged version of the total expenditure. Okay, and then from there on, you can use the sample code and then develop your own to answer those questions. Okay. All right. So. Okay, so some of you were asking about how to use pnorm or like at least like getting the understanding of pnorm itself. So I don't have the code like computing the mu and SD for now, but I'm just assuming that I have them. Okay, let's assume that we have them. I'm just going to do a demo here. So the question is asking you to assess the statement that the average logged total expenditure is 9 or more. Okay, so the question is asking about if you read a calculate, the average of the logged total expenditure is mu. Okay, we use mu as we define is the mean. So the question is asking you to evaluate whether the posterior mu is larger than 9 or not. Okay, and we know that the posterior distribution of mu is a normal with mean mu n and standard deviation SDN. So we're going to try to use this now. And the way to use it, I give you the hint to do pnorm. So let me just type it now. So pnorm needs 3 inputs. Okay. The first input is the number that you're evaluating at, which is 9. Okay. The second is the mean. The third is the standard deviation. Okay. So this will be the code, almost will be the code to answer that question. And if you're not sure about what pnorm does, just go to the console and type $pnorm. The help file going to show up. Okay. So I mean, sometimes maybe not super helpful, but here I want to say that pnorm is computing pretty much like the CDF up to that point. Okay. So some of you, once you run it, I don't have the numbers here for you, but when you run this pnorm function with 9 and mu n and SDN, I think you're going to get an answer to be 1. Okay, but keep in mind, this 1 is the density up, the probability up to that point, which is the CDF. Okay, but the question is asking you whether it's larger than 9 or not. So it's a proper distribution. So larger than 9, meaning like the probability of larger than 9 is 1 minus the probability of smaller or equal to 9. Okay? So ultimately, if you're doing the exact solution, you should do 1 minus this p-norm, and then use whatever the probability that you see. If it's super low, then it's not like supporting the claim, right? If it's large, it's supporting the claim. Okay, so this is how you can use the p-norm function. And then I guess just as a hint for the second part, which is using R-norm, right? So R-norm is now we're using simulation strategy to evaluate the statement. So again, we're gonna use the R-norm function, random draw R. And remember, in previous lab, we were using like a capital S to determine how many draws we're doing. So I'm just doing it generically for you now, capital S. When you do this, this is generating S number of posterior draws of mu, okay? And now I want to evaluate how many of them are greater than 9, right? So right now, this is actual draws of mu. So what you do, you can refer to the previous, like the slides that we have for the beta binomial, but I can just give you the hint now that if you want to evaluate how many of them are larger than 9, you can do like the entire, so this is a vector, right? Vector greater than 9. So this is going to be logical, right? You get a bunch of true and false, right? If you take the sum, that gives you the total number of draws that is larger than 9. And then if you want to get the probability, you use the whole thing divided by S. So this will be approximation to line 3. Okay? So line 5 is the demo of how to use simulation to do it. And then if S is large enough, the results of 3 and 5 should be very close. Okay? All right. Yeah. So this is the so far what I want to share with the hint. But take your time. I mean, again, all of the material, like the answers to those questions, we covered it one way or another. Sometimes it's in the slides, sometimes in other labs, et cetera, et cetera. But if you go back to the material, you'll be able to find it. But of course, it takes some time, and then that's the learning as well. So like, don't feel frustrated. You just need to like keep trying. Oh, yeah. Okay, one more comment. It's a mistake that I did in the write-up. So indeed, also it's in the instruction. So indeed. Sorry, so if you get to the lab instruction, you will see that for question 2, I also wrote p-norm. Sorry, it's a typo. It should be q-norm when you're trying to get the credible interval. Okay, sorry about that. I will update it. But for now, yeah, 4.1, the exact solution, the hint for Bayesian credible interval is not p-norm, it's q-norm. Okay? Yeah. Thanks for catching it. Okay, we have about 5 minutes left, and so before we end, I do want to also give one more hint for the last part, because that might be something I think it's new for most of you. And so this is the task of doing predictive checking. And if you see those 3 steps that I listed for you, you can see that first of all, step 1 is you have to simulate 1,000 sets of predictive values, and each step will contain the number of observations. Okay, so and step 2 is for each step you calculate the sample mean, and then step 3 is you compute, like you compare the simulated sample means to the actual means that you have in the data. So this is new because earlier in any kind of prediction that we did, especially in task 3, question 3 here, you only are generating and you're only generating, like say you're using R norm to generate like only 1,000 predictive values, right? So that's the task. But then when we're doing predictive checking, what we're doing is we're replicating what you might have in the data. So now the replication actually has 2 rounds, or like 2 steps. the first step is you're going to generate exactly the same number of observations as you have in the data, which is 6208. That's the number, which is n. And then you need to do this process for s number of times. Okay, so now you see that it's not only just one time that I'm generating n observations. I'm generating n observations for 1,000 times. Okay, so the suggestion I have for you, so I'm going to do a little demo here. This is probably new to many of you. So previously, we're using R norm to do like S and let's see. Okay, we first of all need to get the mu, right? The mu post. So that's from mu n and SDN, right? So if I do this, I get a bunch of draws for the mu. And then from each mu, I'm going to make a new prediction, right, based on what we have. So say that will be predict. So if I use y predict, that will be R norm, and then S. And the mean will be the mu post, because that's the mean that we have. And then the standard deviation, I think I asked you to use the sample. So I'm just going to use sample to replicate sample SD. Okay, you're going to compute it. I gave you the hint. So this is for question 3, where you are doing just prediction. Okay, so part 4, you have to do one step further. So I said that you're not only just going to generate like S number of new predictor values, you're generating N number of predictor values for one set, and you are doing this for 1,000 times. Okay? So my suggestion for you is you can create a big matrix at the beginning, and then you can store your numbers in it. Okay, so I'm going to show you how to do matrix. Okay, so I name it as y predicted and then the matrix. So you will do matrix, that's the function. And you can, so right now I'm trying to initialize a matrix with nothing in it. So you can do rep, so this is repeat. I'm going to create all of them as NA, so or zeros, whichever you use. I think NA is better because sometimes you might generate zeros as well. Anyway, you can use NA. And then the dimension you're going to have is S, because S times N, okay? So this means that I'm going to create a matrix with S times N number of elements, okay? And let me finish the code so you know what I'm doing. Okay. And also specify that the number of columns that I want to have for this matrix is N. So now I'm having an S by N matrix, okay? So this matrix, I'm using it to store later whatever I'm going to draw or generate. Okay? So if you think about the dimension of the matrix, it's S by N. So S is the number of iterations I'm doing, right? And then N is the number of observations I have. So that means in each row, I have a new sampled data set. Okay? Because there are S rows in total. Each row is a number, represents the new like generated data sets. So next step you can do is you're going to write a loop, because now I'm going to do it one by one. So for example, I'm trying to loop through the S. So it's going to be S in 1 to capital S. Sorry. Capital S here. Okay. And then I'm doing it by row. So that means for each row, first of all, I'm going to get a new post. And this time, I'm generating from the posterior. Okay. Notice here, we're only generating one mu. Okay. You get one mu, and then you get a set of data from the same mu. So that's what it means to repeat, to replicate a data set. Okay. So I get mu post, and then I'm going to get y predict to be R norm. And this time, because there are what? N observations, right? So number of draws I do is N, right? And then the mu will be the mu post. That's just the draw that I did from the posterior. And then the standard deviation will be the sampled SD, which I asked you to compute later, so you can replace that, whatever you computed, okay? So now I get a vector of y predicted value. I have N of them. So what you can do, is now I can save it into my matrix. So remember, the matrix has a dimension of S by N. So I'm saving to the S row, so small s, comma, and then I assign all of my predicted values there. Okay. So once you run this loop, you have filled in the entire big matrix. Each row represents n number of observations from one simulation. Okay. And lastly, if you look at the question, step 3, or like step 2, they ask you, like the suggestion is for each set, you calculate the sample mean. So that means now I have this matrix, I need to compute the row means. Okay, the row mean is going to give me the sample mean of y bar. So you can do row means, that's a function actually. You do row means, y predict, and then matrix. This will be what? The y, I would say y bar sample. Once you run this, you're going to get 1,000 different means. Okay, so this is the vector that ultimately in step 3 that you're trying to compare to. Okay, so this is the hint. I will upload whatever I wrote on the R script. Upload it to Moodle so you can refer to it. And I also, so right now I'm like only recording the lab session as well. So we're going to have a shorter video just about the lab. So if you have questions, you can try to rewatch it. But of course, you can always ask me questions through Moodle or through email. And yeah, so I think part 4, question 4 is a little bit stretched for maybe for some of you, but it's definitely doable. You just need to like sit down and think through the steps. And then hopefully like those hints is helpful enough, okay? All right, I think we're gonna end here because we're running out of time. And yeah, let me know if you have questions. I tentatively planning to have this due 1 week from today, okay?